Okay, good afternoon, everybody, and thanks for joining this training session on the new VRV5, mini VRV5 that's due to be launched. I'm just going to go through some of the advantages of the unit and some of the safety features, and then afterwards we can possibly have a Q&A session as I go through. Make any notes that you want, and we will see if we can answer any questions at the conclusion of the training. Okay, so this will be the mini VRV5S series, which will be the next generation in VRV equipment. What is the aim of the development? Well, due to the Kigali agreement and amendment that has been come into force with the phasing down, not phasing out, but phasing down of R410A refrigerants, Daikin have already proactively developed R32 refrigerants. So they are already in preparation for the 2030 HVAC market, way ahead of any other manufacturers. And the objective is striving to have the lowest carbon dioxide equivalent for any possible refrigerant leaks. So the advantages of this will be seasonal efficiency, lower global warming potential of refrigerants, and also there will be less refrigerant in the units because of the energy content, the enthalpy, and specific heat capacity of R32. So we do not have as much refrigerant in a mini VRV using R32 and comparing it to R410A. If we look at the portfolio on how the R32 came about, 2010, the launch refrigeration products on 410A. In 2012, the launch of the VRV4 with variable refrigerant temperature, which when activated could have a seasonal efficiency of 20% over and above the current efficiencies. In 2013, Daikin developed the first R32 split range. In 2016, the full range of splits and the first Sky Air units came out. Then in 2017, we started manufacturing chillers with R32 refrigerants, as well as HFO chillers, which is another form of refrigerant with a global warming potential lower than carbon. This was not really the Altherma for the South African markets, but we'll fast forward to 2020 and we see the launch of the mini VRV on R32. Daikin are ultimately going to go fully R32 on all VRV systems, but as an introductory development to the market, we have started off on a 4, 5, and 6 horsepower in the mini VRVs. This is the current series that we offer in the mini VRVs. We have single phase units, which is the double fans, as well as the compacts, which are one fan units. Single phase, ideal for houses, 4, 5, and 6 horsepower. Then in 3 phase, we currently have the 4, 5, and 6 in the double fans. We go up to 8, 10, and 12 horsepower as well with the front discharge fans. This is the current 410 series. If we look at the new series that's coming out, this will be R32. It will come out available in single and 3 phase units in 4, 5, and 6 horsepower at the moment. Okay, there's further developments, but as a route to market, the 4, 5, and 6 mini VRV will be in R32. So the product concepts, innovation, and sustainability. So what the development has offered is like-for-like installation and selections, the same as for 410A. All safety measures are related to IEC standards 60335, which is the international standard that Daikin has incorporated to have the safety features on board for flammability as well as toxicity of the refrigerant. We have top seasonal efficiencies according to Lot 21. This is a European standard that Europe worked towards. And at the launch of R32 mini VRV outdoor units, there will be 5 dedicated ranges of indoors. I'll get on to this a bit later, but you cannot, when ordering these R32 outdoors, Daikin have made a new indoor range. You cannot put 410 or existing indoor units onto the R32 range. It has to do with the safety alarms that are built into this new range. So if there's a leak, these new models will trigger an alarm telling you that it's detected a leak. So it's not backward compatible. The new range will also have new indoor units. So the key strategies to meeting the F-gas phase down demands. So Daikin obviously has a very strict environmental policy. It's part of the Daikin policy to always aim at lowering the environmental impact of its product portfolio. So shifting to R32 is a good example. The aim is to shift the entire, which I mentioned earlier on, the entire Daikin VRV portfolio is going to go into R32 refrigerant. And R32 is definitely the next generation refrigerant for VRV systems. Why? It has a third the global warming potential of 410A. R32 products are more energy efficient, and R32 is a single component. So for those of you that might not know, R410A has a global warming potential of about 1,800. Whereas R32 is around 600. So what does that mean? That means if you lose 1 kilogram of R410 into the atmosphere, it is equivalent to releasing 1,600 kilograms of carbon. The same thing with R32. If you release 1 kilogram of R32, it is equivalent to releasing just around 600 kilograms of carbon in the air. So you can see it's a third. It's a huge saving, and global warming potential is obviously the reason that the Earth can't cool down. It's got nothing to do with the ozone layer. It's that this chemical stays in the atmosphere, and the atmosphere can't cool down at night, and the Earth can't radiate its heat back into space. So the heat is trapped and things get hotter and hotter. Further to that, R32 is a single component refrigerant. So conventionally 410 is R125, a blend of 125 as well as R32. And if you have major leaks, you cannot just top up with R410 because you don't know what's leaked more. Is R125 leaked out more, or is R32 leaked out more? So the advantage of this is very similar to R22, is that if there's a leak, you don't need to recover all the refrigerant. You can just top up because it is a single component refrigerant. It's not a blend. R32 also has a very low flammability, which allows safe use in many applications. It is flammable, but we'll get on to that, and I'm sure you guys have seen a lot of presentations on R32. It doesn't burn like a cigarette lighter. It needs a lot of heat as an ignition source, and when you ignite it, the moment you pull the ignition source away, the R32 flame goes out. It doesn't self-combust. So if we look at the key strategies to meeting F-gas phase down demands with lower global warming potentials, what we do is, okay, here they say the global warming potential, I was a bit out with my figures, but R410 is 2,000. So you lose 1 kilogram of 410, it's equivalent to 2,088 kilograms of carbon, whereas you can see R32 is much lower. And also when you look at the charge, R32 uses 10% less refrigerant charge. So when you combine the global warming potential as well as the charge that you've got to add into these systems, you generally see that the overall environmental impact, if there's a leak, we're using less gas and the gas is less harmful, there's a 70% reduction in what it can do to the environment. Okay, so it's only 29% damage to the environment compared to 410 doing 100% damage. So it's pretty much a no-brainer for Daikin to have gone to select, because of the environmental views, they went for R32 refrigerant because of the environmental impact. So when you develop these systems and they have a refrigerant that is flammable, you have to apply to legislation. So Daikin chose to use two different standards. First of all, if they used I'm not going to bore you guys too much with this, but there's a generic standard, which is EN, the European National Standard. They call it 378. And in the standard, if you open this book, it talks about toxicity, which is how poisonous a gas is. And it also talks about how flammable a gas is. So both standards tackle safety regulations. But what Daikin decided to do for flammability was to rather use another standard, which is the IEC 60335. And the reason they used this standard is because it's a lot stricter. It's got more rules in it, and Daikin chose a more difficult standard to comply with a lot more stricter and stringent rules. So, yeah, classification of refrigerants according to safety groups. Refrigerants are toxic. Not that you breathe them in and you're going to lie on the floor choking to death. They're toxic in the sense that they asphyxiate you. They cut off your oxygen supply to your brain. It's not that you breathe it in and it tastes very bitter and all of that stuff. No. So we label refrigerants depending on how toxic they are with an A or B, and also how easily they burn when you bring them in the presence of an ignition source. So you have digits 1, 2, and 3, and letters for toxicity. And here you can see we used IEC 60335 and EN. So there's two standards Daikin have used. We can see here that R32 falls into a lower toxicity group as well as low flammability, and 410 also falls in this group of an A with a 1 because it's not very flammable at all. R32 slightly flammable, so it gets the letter 2 on it. So for a flammable gas to ignite, specific conditions need to be applied. First of all, you need oxygen. Then you need fuel, which is required to be a mix of refrigerants in the right percentage of air. Then you need a heat source to light it. So if you look at this rating, A2L refrigerant, which is what R32 is. So they say if all circumstances come together, say if you've got oxygen, you've got a flame to light it, and the fuel will be the R32, you will see they'll burn very, very slowly. The burning velocity of less than 10 centimeters a second. So, I mean, propane, butane, acetylene, that's crazy speeds that it burns at. This travels and burns very, very slowly. And if we look at the gas, the MRE, which is the minimum ignition energy, that's rated in joules of R32, if compared to that of other natural gases, is 50 times higher. So the higher the minimum ignition energy, the harder it is for the gas to burn. And here you can see these numbers are much higher. Butane, very explosive natural gas that you cook on, your gas bottles. Acetylene, also very explosive. And hydrogen, too, super explosive. R22 and 410 don't comply because they don't burn. But you can see the higher the numbers, the less that it burns. If we quickly have a look at this, if you have in a room 0% air, that means you're in a total vacuum. This is a volume of air in the room. We can see that in order for R32 to burn, you have your lower flammability limit and your upper flammability limit. So when the air volume gets to around 31%, sorry, between 14 and 31% is only when it will burn. So it's a very low flammability, these units. Right, let's talk about toxicity. Both R410A and R32 are classified as A regarding how toxic they are. And I'm going to mainly focus on these numbers here. These are the toxicity limits. So what does this mean? 0.44 and 0.3. What this pretty much means is for 410A, you can't have, in order for it to become poisonous for you to breathe in, if you're sleeping in a hotel room and there's a leak on the split unit and all the refrigerant leaks to the floor, it will settle on the floor because it's heavier than air, and it'll gradually displace upwards, and then you breathe it in at the height of your mattress, and you'll never end up waking up. You'll die in your sleep. So what they say is then, in small little hotel rooms and that, you can't have more than 440 grams of 410A per cubic meter of air. They're a bit more relaxed with R32, 300 grams per cubic meter of air in the room. So length times breadth times height, you'll work out the volume of the room, and you can calculate all the refrigerant in the system, and you can see, oh, it's if it's higher than that, it's more risky. So if there's a leak, so let's say it's 0.35 here or 0.68 or whatever, there's a higher risk of somebody dying in their sleep if there's a gas leak. So we like to have 300 grams or below on the system. If we look at this diagram, which can look a bit complicated, let's just look at the room area here. This isn't volume, this is just square meters. And we're talking, say, 410A here. And this is the roof height of, say, 2.5 meters. It's more practical terms if we follow what is stated in the standard EN 378 for 410, the charge limitations regarding the space area marked by the blue line. So this blue line here is what we use. So in a nutshell, if we use the EN 378 standard, at 8.8 kilograms is the limit for a system before toxicity becomes a problem. So if we had to draw a line down here and the room was, say, 15 square meters, this is where we could apply. If there was 10 kilograms of gas or 12 kilograms of gas in the system, because it's a long pipe run, and we here, you'd see we'd fall into this cross hatching, and it wouldn't be advisable to use a system on a room this small with that much gas. So the limit here is about 16 kilograms and about 20 square meter room. Okay. So, but like I said, if you have a small room, 10 square meters, the most gas that you can have in the system is 8.8 kilograms. Okay, you can't have more than that in case of a gas leak. Then the room becomes too toxic. For R32, that is 8.8 kilograms for 410. For R32, we drop that to only 6 kilograms. Because of also the way it's been rated. So on a room up to 15 square meters, you can put more refrigerant in the system with 410A. They're a lot stricter with R32, and you can see here we have a limit of only 6 kilograms. But there's a twist. We can offer the same amount of cooling though with less refrigerant charge in the system. So if this system was designed on, say, a 6 horsepower system, I would need 8.8 kilograms. If I put a 6 horsepower system of R32, I would be I'd drop it down to 6, but because R32 is more energy efficient, I might not need a 6 horsepower system. I can use a 5 horsepower system, which will use less refrigerant in it than a 410 system. So you can downsize an outdoor unit onto R32 because R32 has more energy efficiency and it's got more energy. So you might, like I said, you can use a 6 horsepower 410A, but you can select a 5 horsepower maybe in R32 and you're going to get the same cooling. And then a 5 horsepower will use less refrigerant. If we add these two together on a system, so for a typical VRV system with a total refrigerant charge of say 9.5 kilograms, the minimum allowable room size will be 8.6 meters squared. However, if we use R32 system with the same layout, the total refrigerant charge will be 10% lower. So if we take 9.5 kilograms, we know that the R32 system uses 10% less gas. You take 0.95 of that, you subtract it, and you'll get 8.6 kilograms. Now the room size can go up to 11.4 meters squared. So now you can have a bigger room area if you go R32. If I take 8.6 kilograms across because it uses 10% and I drop that down, I see that my room size can go up to 11.4 meters squared. Right, this is what everybody panics about, is the flammability. So the standard that Daikin used describe potential sources of leakage. They define them. So the standard says piping with joints must not be considered as a potential source of a leak. As an extension, also ref nets and headers won't be considered. So the standard does not consider ref net joints potential leak source as well as piping. Okay. The standard also says indoor units, which is BS boxes, EKE boxes, need to be seen as potential sources of leaks and countermeasures are required. So in a nutshell, ref nets are excluded. I've put here a tick. Even your outdoor units not considered a source of leak because this has primarily got to do with leakage where people can be staying. So if these BS boxes are in a ceiling, in a passage, and there's a leak, there's a low possibility because of supply air and extract air that the leak will just get sucked out. It's not always the case in a hotel room. So they have classed indoor units as your risks. And they've said this is where the leaks are possible and where you can get flame propagation. I'm not going to go through this whole standard, but they do give definitions of a room here. That's why I've put this little star. But what am I getting at here? I'm getting at this. If you don't put your condensing unit outdoors and you put it inside, say on a parapet in a block of flats where it doesn't want to be seen, this is the minimum dimensions you can use. Or else if this leaks, it's not free to atmosphere. So you have to use a ratio. 75% of the louver must be free and the louver must be 80% of the wall. But I'll share this presentation with you guys and you can go through and read up on these standards. Looking at flammability, and we're back to room area now, the size of rooms. We've already established that the hatched area has been tackled by the standard 378 toxicity limits and is not in scope of the VRV system. Safety measures required are not the same as for flammability and are therefore much stricter. So anywhere where there's a fire, these standards are much stricter. And what do they mean? Like you need an alarm with a dedicated safety power from batteries, etc. So that they've said here that the remaining light grey area, which is this area, and not the hatched area, so this is the hatched area, will be subject to the restrictions. So this is the grey area is in scope, and this is what Daikin will be following. So if we look at this in a more practical way and based on extensive analysis of VRV systems and VRV Web Express, so what they did in Europe, they've looked at all the online designs from all affiliates around the world. So every time you do a design, it goes through to their server and they look at what is the most common design and pipe runs. And what they found is typically that the total piping lengths on most people's designs run between 90 and 110 meters. And what they've also found is because these pipe runs are so long, typically you need to add extra refrigerant. And they've calculated that normally you got to add double the refrigerant charge based on a lot of designs that people have done around the world. So if we look at this, if we consider that the factory charge of a VRV system will be around 3.5 kilos, so that is what the factory is going to put in to the outdoor unit for you. It will come shipped with 3.5 kilos. And also that an R32 system, when compared to 410, has 10% less additional charge. We will get an additional charge of 3 kilos. So that sounds a bit confusing, but what they pretty much mean is because they said most countries are using double the charge on a 410 system, 10% is if you take 10% and you subtract 0.34, you'll get 3 kilos. So now what they've worked out is that on a typical R32 design, you're going to get a total charge of 6.4 kilograms on the system. Excuse me. So what they've said for a refrigerant charge of up to 6.5 kilograms, if you've got 90 to 110 meter pipe runs, the VRV5S system can be installed in applications with a room as small as 10 square meters. Okay. I know this seems a bit complicated. It's the first time you're seeing these graphs, but if you read through it and go a bit slowly, you should understand it. So Daikin is the largest application area that results out of the combination of the solid dark and lighter blue area. So all the designs that have been done around the world, a lot of our equipment falls within the dark blue and as well as the lighter blue. So for all applications that have a charge between 3.5 kilos from the factory and up to 6.5 kilograms of additional charge, so that's if you add in another 3 kilos, the smallest room area, as I've mentioned, can be 10 square meters. For applications in the blue dotted region, they are out of scope. So you can't have systems with this amount of charge up until 30 square meters in this hatched area. It falls out of the scope of the product. So for units, talking still about flammability. For units installed in the lowest underground floor, so if you have a certain basement or whatever with a roof height of 2.2 meters or higher, and due to the Daikin development, there's 2 additional measures. For a refrigerant charge of up to 3.9 kilograms, the VRV5S system can be installed in applications still with the smallest room of 10 square meters. And Daikin has the largest application area, which is very similar to what I've mentioned on the previous slide. This is also more about basements, so I'm going to sort of skip this slide. And I just want to summarize what I've got. So in summary, the change of 410A to R32 refrigerant has a small practical impact in terms of toxicity. So 410 is just as dangerous as R32 when it comes to being toxic. Only flammability that R32's flammability is a new factor that needs to be considered in terms of refrigerant safety. Daikin use IEC standard 60335 because it's a lot stricter than the 378. And in order to maintain the VRV flexibility and comfort while maintaining the same high safety standards as for VRV4, the VRV5 series was developed to the requirements of these standards. So they like to sort of brag about the sort of standards that they've added. So importantly, because there's flammability and toxicity, we have had to implement safety measures. So, sorry, just give me a second. So there's three possible countermeasures that you can have in a minimum room area or in a total system. You can have an alarm system that goes off, warning you that there's a leak. You can have shut-off valves, or if there's a leak, you can ventilate. So fans can switch on, or you have automatically louvered windows that open and you bring in fresh air to dilute the R32 refrigerant leak. What Daikin decided to do was to not use any third-party mechanical ventilation. Instead, we have put alarms in the indoor units that go in the rooms, which are audible. So your remote control will start beeping and making a buzzing sound. The remote will also show a red ring, and it'll also tell you that there is a leak. Further to that, the outdoor unit will shut down. It'll do a liquid line shutdown on pump down valves. So there's a liquid line valve which will shut, and the unit will do a pump down to prevent any liquid still being pumped through the system, because liquid has expansion ratio of about 400 to 1. So it expands 400 times its size when it turns to vapor. So what are the alarms used for? The alarm is used to warn of a leak in the occupied space. Obviously, the alarm will be activated when a leak is detected through the refrigerant leak detection system. It's no good having this leak detection system if it can't be visual and audible, which is what I've said. We've incorporated an alarm as well as a red ring that will come on the remote control. At least one alarm should exist in the occupied space where the leak occurs. A local safety alarm can't be considered as appropriate measure where occupants are restricted to their movements. Where people are restricted to their movement, the alarm needs to give the signal in that occupied room. And at a supervised location. So if you're living in hotel room number 4 and the leak is in your room, the alarm must go off in your room, as well as a supervisor's or maintenance office. They must also get an alarm. It's no good having an alarm in the passage if there's a leak that's been detected. Nobody will know what to do. There'll be panic. What do we do? Is it a fire? Is it this? No, it's just a leak alarm. So each room needs its own leak detection, and it must be also connected to a supervisor who's monitoring the alarm systems. So if we look at the alarm, it'll be on the BRC remotes, and these will come out in new models, which has just got a number change on them. So with the alarm, there will be 3 configurations possible through the settings. On the remote, there will be a remote control with the alarm coming up, so applications requiring remote controls. Applications, then we can also have an alarm only, and then the supervisor will also get an alarm coming through. The alarms as required by the rules or legislation, so you need the Daikin R, which will be a red LED, which I've mentioned, and it's going to flash and blink to get your attention. And it's also got a buzzer that's fairly loud at 65 decibels, ensuring that everybody can hear the alarm going off on the remote control. I'm not going to go through this with you. Obviously, everything was also detected on your phone remotely, but this is just the process. If a leak is detected, notification will happen on the remote control. The alarm on, the buzzer will sound, and then Daikin R will go red. That says there also notification on the Daikin app when you have it on the phone, the leak detection notification. On the notification area and also the alarm area will be highlighted. Then once the alarm stops, the sound off, light off, you'll still have the remote control displaying the notification. And the app on your phone keeps the notification, so it won't overrule the remote control. Now, importantly, group control is not allowed because you cannot, even if it's an open area, you cannot daisy chain units together. Each unit needs its own remote control because each unit has a potential leak, and this unit might leak and there's no remote to warn. This might be 25 meters of cable away from this remote. So group control, unfortunately, is not allowed. If there's a system, as I was mentioning to you, if there's a leak on this system, there will be a system error on the other remote controls showing, hey, we've picked up a problem, but these end users won't know what the problem is. They'll just see that the air conditioner stopped. But if this is your room, you will know that the leak is in your room and it will be blinking red. You can also, depending on the building, have a supervisor alarm if there's somebody that sits in a control room and monitors things. The supervisor's remote, so as I said, it's not possible to turn off the alarm from a supervisor's remote. So if this starts buzzing and the guy's too lazy to get up and go and see what the heck's going on, he can't silence the remote. And he can't push a button here and stop this alarm going off. That won't work. So you'll have one single P1, P2 connection to any unit, which I've measured already. The supervisor's alarm will provide a visual alarm, an audible alarm, and it'll also say the remote control address on which alarm is going off. You don't have to, for the supervisor's alarm, you can also hook it into any one of these P1, P2s, whichever is closest to the supervisor's room. Further to this, you can add the iTouch Manager onto the VRV5, and there will be an output. Once this receives a leak alarm, you put that into a WAGO module, and that WAGO module then make or break. It's digital, so it's going to fire a switch, and it's going to trigger a third-party alarm if you want. Further down the line to alert another supervisor, and instead of him just having a little remote, you can make the alarm more audible and more visible and flash like, hey, there's a big problem going on. They can quickly look on the iTouch and they can see which room the leak has occurred on. In this case, it's for the fully flat cassette. The supervisory alarm, there is the optional PCB, which can be ordered. There should be more details on that package coming off, which I should have for you in the later in one of these slides. If we look at the shutoff valves now, the shutoff valves, the calculations that served as a base for the development of the shutoff valves were made considering the worst case scenario. Okay, so they considered the worst kind of leaks possible when they made these calculations and incorporated them into the R32 outdoor units. The shut-off valves are installed in the outdoor units, which are generally installed outside. In case they're not installed outside, they need to comply with the measures already defined. I showed to you earlier on. If you want to put them inside and have a louvered box to comply with the leaks, you have to have the certain dimensions. And the shut-off valves don't require separate power supplies. I presume they work very similar to solenoid valves, like on chillers, where there'll just be a relay that goes that de-energizes a coil, and the coil will drop with a spring, and it will do a pump down in the liquid line while the compressor is running, and then the compressor should go out on a low pressure alarm. So safety measure logic, we'll see if an R32 system leak occurs. Here's the leak, say in this guy's room. The leak will now be detected by the leak detection system, which is built into the indoor units. An error code, an audible alarm. So there's the little buzzer, and this is going to go red. It's going to make a sound. So the error code, an audible alarm, and red warning signal will be generated by the remote control of the unit where the leak has occurred. So it'll happen on this remote. Different error codes is displayed on the remote controller than that of the other units. So these units might say A1, this one might say C6, because this is the faulty unit, okay? Excuse me. No alarm or warning lights are activated on these rooms, okay? The alarm's only going to go off in the room where there's a leak. If a supervisor's remote control is installed, it will also display the error code with the leaking unit's address, as long as audio alarm and warning lights. And remember, the supervisor can't switch off and disable the alarm. It has to be investigated. After the sequence of functions and minimizing leaks and risks have been completed, the system will go into a locked state. So it'll lock out. The remote controller of the leaking units will display one error code, and the remote controllers of the others another one, which I've mentioned to you already. This is just sort of repeating itself. When a leak is detected, an authorized service team needs to be called to repair the leak, and I also identify and see where the leak was, and then they need to reactivate and restart the system. Okay. It is possible to stop the leak detection alarm from the remote controller and from the app on the actual unit. Okay, so if you have a cell phone and it's talking only to this unit, you can stop the leak detection alarm and buzzing. So in summary, Daikin will integrate 2 safety measures which will come standard from the factory, offering to the market the best possible like-for-like R410 system. So you don't need to go and buy extra safety things. There's pump down valves and there's a leak detection system. The implemented additional safety measures are an alarm, obviously, so it's both visual and audible for the indoor, and the outdoor will have shut-off valves. No additional work is needed during installation and commissioning of the system when compared with the VRV4S. The use of ventilation as an additional measure is very challenging and costly. So if a hotel wants you to do this, it sort of can be done, but it is challenging and it is costly. So you got to install 1 VAM per indoor unit, which gets too costly, and also too challenging, not enough spaces. You can also install local fans per indoor units, driven by our VRV5S. So we do supply a voltage output on this board. But if you have 20 indoor, well, you're not going to have 20 indoor units. It's a mini VRV. You might have 3 indoor units. We can supply a voltage output, but then you're going to watch what size fans you use. So you need to pull them in with relays. So they're going to pull too much power and they're going to blow the board. Or you could install a central ventilation system. Example, an air handling unit. The safety requirements with regards to the the AFR are a lot higher than for comfort cooling. So The good thing is the Daikin VRV selection software, when you design it on VRV Express, will inform the user whether the system has been designed to comply with legislation. Now, the only way to comply with legislation, you have to put the pipe lengths in. And I don't know if the software is going to allow you to just do a design with R32 if you don't put the pipe lengths in. They want to know the pipe lengths to let you know if there's too much refrigerant in the system to leak into the smallest room. That is the risk. So let's have a look a bit more at the product now and material names. The new VRV5 S range is going to have the letter A in it and no longer the letter Q. They will come out in single phase, as I've mentioned, and 3-phase, 4, 5, and 6 horsepower units. So they're ideal for housing and residential developments where there's not any 3-phase power. These are the indoor units that have been designed specifically for the VRV5. Interestingly, they've gone right down to a 1 kilowatt ducted unit. This is because I realized that sometimes there's even like a very small little server room that might be very, very small, and a 2 kilowatts unit's even too big. So this is a new design allowing 1 kilowatt of cooling capacity and a low static pressure. But this is the range that you're going to get. Bear in mind, this is still mini VRVs for now. So we only go up to a 6 kilowatts, which, if my math says, it's about 6 horsepower, which is about just over 14 kilowatts. Okay, so you could put one big ducted unit on say a 6 horsepower, 14 kilowatts. These units, we've had a bit of a delay, but I think they've come back on schedule. Will be available certain ranges from September this year, so from next month. The unit that does have a delay will be this mid-wall split. They had issues, I think, a lot of the coronavirus, and they've pushed that to January 2021. So if any of you want to start installing and using this product, you're not going to get the mid-wall split until late January 2021. So the majority of the units are available from next month, with the exception of this mid-wall split. That is the delay. We're not going to go through this, but this is pretty much our data books on the system with the cooling capacities, 12.1 up to 15.5 kilowatts, and there's some recommended combinations, generally 4 units max, which we like to put on these mini VRVs. They have on seasonal energy efficiency ratios, they're very impressive. We don't work on EERs unless you use a unit purely for a fixed cooling load. For example, a process plant where you say melting plastic pellets and you've got constant heating load, then SEER doesn't come into effect. Then we only use EER. But the main application for mini VRV5 is seasonal energy efficiency ratios. And you can see they're very impressive for cooling, 8.19s in the 7s. They're all running over 7, which is fantastic energy consumption. These are all the data sheets which you will get to see on the presentation when I share it. There's also some information on the individual units available that plug in. There I was telling you we go down to 1 kilowatt for a very small application. As I was telling you, excuse me, you cannot, these are not backward compatible. You cannot put VRV410 units on an R32 and vice versa. R32's got to be for R32. It's dedicated because of the leak detection system that is built in on the indoor units. So what are some key selling points and features? Why is Daikin calling it the best VRV ever made? So let's look at a few things. You will be able to connect the VRV5 to air handling units and do X, Y, Z and W control. The new EKE boxes are currently under development. They will be launched also around September, October. The Biddle air curtain, which we don't really use in this country, or Namibia where you guys are, and it's also got an automatic test run. For now, however, you cannot connect the VRV5 to any hydro boxes to make hot water. It's primarily got to do with software configurations, so it's currently under investigation and how to include this into the solution. It will become made possible as research and development department develop these PC boards further. You, for now, also will not be able to connect any fancy Sky Air or like the Amura range split units onto the mini VRV. It'll probably come out later. The reason that we do offer that connection, and you need this little box, because bear in mind, if you select a Sky Air unit or a fancy looking or the one of the curved Amuras, the reason you need this box is because this is where the expansion valves are. So if this was a normal split unit and you like the look of the indoor unit, there's no expansion valves on the indoor unit. The expansion valves are on the condenser. So as such, Daikin have had to build this box, which you put as close as possible to the split unit, and then you can use it. But for now, cost impacts on RA units to include the required additional measures. They're going to have to include leak detection on the current Amura range. So they're looking and they're saying it might be a bit too expensive for now. And for now, there's no automatic refrigerant charge possible. Why? Because of the legislation. So if you use R32, you have to calculate the charge according to your pipe run. So your installation has to be accurate. Legislation does not allow automatic refrigerant charging of a VRV system. Those of you that may or may not have worked, it's easy to connect to your PC, the outdoor unit, when checking and doing commissioning with the VRV configurator. When comparing the 410 system with the R32 system, we've just sort of done a few highlights here. The nominal efficiency is improved by 7%. That's EER, and your seasonal efficiency is 12% better. They also have a lower height. They're smaller units because they're using R32. Okay. Reduced weight. The AFR, which to be honest with you, I do not know what that means. And your sound values. They have the same flexible piping configurations. You will find, though, that on some systems going forwards, there will be a saving on R32 because R32 has got good energy in it. Your suction pipe can be one size smaller. So if you're using a 5/8 pipe, you can maybe use a 1/2 inch. That will be on our current Sky Air and Splits Air range. You'll see the pipes are smaller. It's because you use less charge and the refrigerant has more energy in it. It's like petrol's got a lot more energy when you burn it than diesel. Okay. And another advantage, as we said here, it's lower global warming potential, lower refrigerant charge, and the piping connections. And this is pretty much what I mentioned to you about the reduced piping sizes. The newly redesigned compressor and heat exchanger allow to reduce piping sizes across the whole range of indoors and outdoors. There's also further reduction of refrigerant charge. You use smaller copper. It costs cheaper for the person to install. The Mini VRV5, they've put better carry handles on for better ergonomics. They have made the door now with only one screw. There's not like 15 or 20 screws to undo. You take out one screw, you lift this panel, you crank it sideways, and the door mechanism almost rotates like as if it's hinged. Because of this, they've also made easier access. They had a lot of complaints with the previous VRVs. So there's full access to most parts, pressure sensors, thermistors, expansion valves, easy to get to now. Okay, you don't need to strip off the machine. Circuit boards, fairly easy, your high pressure switch. So nearly everything's available just by taking out one screw, and then the door hinges and it unclips. Excuse me. Another unique design is this crazy looking fan that Daikin have developed for the VRV5. The weird thing is it's asymmetric design. It's not symmetrical. You can see each blade looks different. This is rather crazy, the way they've done it, because you need to balance this. This is going to tumble terribly without good balancing weights on it. But they've sorted that problem out. But why do we make an asymmetric fan? Well, first of all, it's going to increase the airflow rates. And it also stops resonance. What do I mean by resonance? It stops that woo, 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 woo effect because it's asymmetric. So it destroys any resonant waves that come along. And this also maintains lower sound levels. Increasing rigidity is a more reliable option, according to their R&D testing. And it keeps power input low. They've done tests, and this fan design has shown an energy reduction. So it has 4 key features on it just by changing that fan. Another advantage is the design grill. On previous designs, there was a large loss of air in the flow area. If you look at the way these vanes have been staggered, but Daikin now have optimized that design. It takes into account the distance between the discharge grill and the fan propeller, and they've improved the air discharge, so there's less back pressure on the fan. They've also had to adapt the grill design to ensure safety for children and adults, where they put their fingers through. Another advantage of the VRV5 is that if you live in a complex or something where people complain, or your outdoor unit's too noisy at night, you can set the sound pressure level down to 39 decibels. The 410 one only has 3 settings. The R32 VRV5 has 5. Okay, but bear in mind you're going to lose capacity if you lock your outdoors. If it's a very hot night and you're dying of heat, but your neighbor's complaining about the noise, it's a sacrifice because we are limiting the fan speed. So we limit the fan speed, we alter the head pressure control, and we don't want, so we have to monitor head pressure control and condensing temperature, which will all have effect on the saturated temperature going into your evaporator. So these are all fancy decibel ratings, which we're not too worried about, but you can see here the capacity ratio. When we do drop, when we go to a low noise level 5, the unit's only working at 30% its capacity. So that's not ideal on a very hot night. Ironically, on the other side of things, we can also increase the ESP on these fans. So external static pressure can reach 45 pascals. So the good thing is you can put a little duct cowling on here to push the air through. There's 3 different settings. The ESP pretty much means external static pressure, as you can read, and what that means is that is the work that the fan has to do to move a volume of air. That's put simply. That is the work that the fan has to do to move the volume of air. We're also a leader in the market. It's the first time in industry that a 3-row coil heat exchanger is being installed for a front discharge unit. You can see there's 3 rows. Optimized heat exchanger piping and fin pitch. Fin pitch is pretty much the spacing of the little aluminium slots. We call it fin pitch. So we ensure that there's optimal seasonal efficiency from a single fan. So there's only going to be 1 fan here, but R32 having the energy it does, we also managed to run slightly smaller condenser pipes, so it increases our overall geometry to give you a bigger heat exchange area for the same sort of footprint. It has a low height unit compared to the double fan, 870 high, which still makes it less than a meter, and there is a 35% height reduction when compared with a double fan. It's a little bit fatter, obviously, because the condenser coil curves more in to just maintain that same condensing capacity. They say lightweight, it still weighs 2 bags of cement, my eyes, but it's 102 kilos, so it's definitely 2 men to carry it. Further technology that we use is so the normal units use standard or opposition who use non-Daikin rotary compressors have moving parts that are made of 2 individual components. So this slide is going to slide up and down, and it's going to make a contact surface with this rotating, it's not a scroll, it's a rotary. So the problem is you're going to get pressure loss in a low pressure zone. Okay, you're going to get, as these geometries change, you're going to have different low pressures where you're going to get a pressure loss. You're going to have high abrasion, which generates high temperatures, ultimately leading to seizure of the compressor because the oil gets so hot and the oil also deteriorates. You're going to have lower compression efficiencies because of the bypass factor. The gases can bypass because this is only loaded with a spring. However, if you look at Daikin, we do not have these separate components, and there you can see bits of wear metal that eventually collect on the rim of this volute. Daikin, however, we have a solid casting for our compression. So we call it the swing compressor, and it's unique. Only Daikin has it, and it's patented. You can't have any abrasion because compared to this. You can't have any refrigerant leaks because this is a solid casting. Refrigerant can't leak past this surface because there is no surface for it to leak. That means because there's no internal leaks, we have high compressor efficiencies and also increased system lifetime. These compressors last a lot longer than these normal non-rotary compressors. The developers have also added valves now at 45 degrees instead of flush. I presume it adds some advantage to installers when they feel it's easier to add and remove their hoses at a 45 degree angle. The VRV5, the cooling and heating selector input has been reintegrated. In the past, you would have to buy that as an optional extra. So that has been reintroduced. The refrigerant cooled PCB is also obviously there to ensure longevity and trouble-free operation. So there's all the liquid refrigerant running through, cooling down the thyristors and IGBT module. Obviously, we've designed specific software to handle R32, and it's got the 3-digit 7-segment display for field settings. This is one of the outputs that are available that I was telling you about earlier. The SVS output terminal, you can maximum voltage, you can put out 40 volts DC. So a terminal for external output is available in the outdoor units. This SVS output can be used when additional countermeasures are required, like maybe a coil or something. The SVS output is connected on terminal X2M. So what we're pretty much telling you, we can give you a 40 volts DC output. Then we have this further integration, they call it the SVEO output, is a contact on terminal X1M that closes in the event of certain errors occurring. A list of errors will be given in the manual. So this contact now doesn't have 40 volts, but it has 220 volts. But just be careful, whatever you plug onto it, it only supplies half an amp of current. So put anything that draws more than an amp, it's going to cook the power supply. For SVO connection, it's recommended to use obviously shielded cable. The shielded cable must be earthed, and whenever you earth a shielded cable, you only earth the one end. On the units where you plug it in on your other units or whatever you're plugging it in on, you can generally leave that earth off. What it does is prevents what we call capacitive coupling, and it just makes sure the voltages are true. That being said, this is a higher voltage, so that is, but on the lower voltage stuff, your F1, F2s, you don't ever earth both ends. You don't earth the VRV outdoor, then go all the way and earth the furthest VRV indoor unit. That's not going to work. And they've also changed the position of the F1, F2, which is obviously our communication network, to allow the addition of a ferrite core. What a ferrite core does, it deals with harmonics coming into the system and any noise. That's probably the ferrite core at the back there. We take the cables through, and it acts like a big sponge, and it absorbs any of the interference and noise that is coming in from the building supply. And another reason they've done it too is to make the mini VRV more usable for residential applications and radio noise. So because this VRV switches on and off at such high frequency, it actually becomes a transmitter, and it transmits radio waves. And if you have certain equipment like your hi-fi or your satellite decoder or your TV very close to the VRV outdoor unit, when the VRV outdoor is running at full power, it becomes like a transmitter, and it transmits a radio noise, and this radio noise can cause interference on your electronic equipment, can cause your radio station to lose signal, can cause your TV picture to go crazy. Yeah, it's to digress slightly. If you look at your microwave oven in your house, and you also have your router in your house to distribute signal to your bedrooms, if your router is standing very close to your microwave oven and you use your microwave oven and you use it on full power, you will find that you might lose signal to your bedroom, to your lounge, because both the microwave oven and the router work on around 12.1 gigahertz frequency. But so they're both equal frequencies, but because the microwave oven works on 2000 watts at least of power, and your router works on 300 milliamps of power, the router gets cloaked by the microwave, because the microwave has now become a transmitter, and it blocks all the signal coming off the router, and you lose your signal. So very similar thing they've done here. with the VRV, so you can use it at your house, is they put noise filters in so it doesn't affect your routers and your cell phones and your TV and your hi-fi. The dedicated indoor range, again, that I've told you about. Dedicated range of specific indoor units has been developed, tackling almost 80% of the market applications. Okay. A new 10 capacity or 1 kilowatt class has been developed for slim ducts for small areas, which I've mentioned to you already. So pretty much what the 410A systems offer, we offer almost everything that the 410A offers. You might find that the 200 and 250 class are out of scope. So it's not included on this portfolio because then the indoor becomes too big for the mini VRV's capacity. This is the PC board we were talking about earlier on that I said I'd get into a bit more detail. The relay PC board ERP 01A5 will be available as an option for indoor units. What this does is it's a relay that sends a signal to field supply devices like a third-party alarm or a mechanical ventilation system in case there is a leak detected. So instead of using iTouch Manager and all the more expensive stuff, you can just order this board and it can, if there's a leak on that indoor unit, it says there based on that signal, the field supply devices will start operating by its own power supply. If there's a false detection, no signal is sent. So it's pretty much a third-party information PC board. The downside is you need one relay PC board per indoor unit. Okay, and it is also no external power supply required. Why? Because the X40 connector provides communication and power. And I've put here in red that the power supply is for the PC board only and not for any ventilation. So this would be like a normally closed, normally open, or a volt-free contact that this would send out. So this doesn't put out voltage. The outdoor unit will do, but not this. This purely the electricity it gets is to drive its own electronics. So in a nutshell, there's also storage and control from the cloud. Europe have got involved with all these different app manufacturers, Amazon and Google with wireless LAN adapters. So yeah, in concluding, they're claiming it's the best VRV ever made. Why? It's the most environmentally friendly. Because of the lower GWP refrigerant, it has the lowest refrigerant charge for doing the same amount of work. Most energy efficient mini VRV. It's got factory integrated, third-party approved, picture's gone over a bit of the word there, but alarms and leak detection systems. There's less material used in manufacturing. So Daikin say that less resources required, it runs cheaper and less environmental impact. Reliability is taken on a very high level. It offers a single fan, which results in a low height. Very versatile unit, and it's the most intuitive VRV ever designed because of the leak detection and shut-off valves technology. And that concludes the presentation. I don't know if any questions have come through. I did hear no questions. Does anybody want to ask anything? Hopefully I can answer. If not, just drop Johanna an email and he can forward me the requests. Okay, if there's no questions, Johanna, if you want to conclude and thank the guys, and then I will stop the recording.
Oh, well, first, thanks, Mark, for your time. Appreciate it. It's always informative. All the guys from Starker and Namibia side. We appreciate all of you. We appreciate your time on a Friday. Starker has mentioned to us that going forward, they would appreciate if we do these type of sessions more often on a broader product base. So we'll keep you posted as to what's going ahead, and as we change and adapt to what we currently work with, it will be good if you guys can always join us. But we'll send out the schedule for that. So thanks, guys. Please, if there's anything, either chat to Richard, or you can forward your questions to myself as well, and we'll take it from there. We hope it's a good weekend, and we'll see you guys in the next session. Richard, I don't know if there's anything on your side